Yeah. So we are doing inverse Laplace transform using partial fraction expansion method. Okay, since we are asked to find out the inverse Laplace transform in this particular topic, we will be given the signal in Laplace domain. So if we apply inverse Laplace transform on that, we'll obtain x of t, the time domain signal. So from Laplace domain, we have to obtain the time domain signal by applying inverse Laplace transform. Okay, now the given x of s would not be in the form which is suitable for applying the inverse Laplace transform. So we have to use the partial fraction expansion to bring it to the proper form before application of inverse Laplace transform to obtain x of t. Is that okay with you, everybody? Yeah. So let's take the first x of s that they've given. So the problem statement would be this: find inverse Laplace transform of the following. They'll say, or they can also ask us to do this: obtain the time domain signals from the following x of s. So both mean the same. Understand that? So they can ask us directly to obtain the inverse Laplace transform of the following. Okay, or they may ask us to find out the time domain signal given the Laplace domain signal x of s. So it's both the way, in both the cases, what is it? It's finding x of t given x of s. Understand that? So the first x of s that they have given is this. X of s that they've given is, copy down this everybody, 2s plus 4 divided by s square plus 4s plus 3. Okay, now we need to factorize this. We need to factorize the denominator. Understand that? So factorizing the denominator, how does it look like? Which are the two factors? So you can do that by using the calculator, or manually, left to you. Use the calculators because you need to know how to obtain the roots using the calculators. Okay, so the roots are -1 and -3. Understand that? So that's why it is s plus 1 into s plus 3. I hope you would be able to do this using your calculator. You will get your roots as -1 and -3. If it is minus, it will be written as s plus 1. Okay. If it is plus, we need to write it as s minus 1. Okay. So therefore, by partial fraction expansion, method, okay, x of s can be written as what? 2s plus 4 divided by s plus 1 into s plus 3, what we have there after factorization, okay, can be written as a by s plus 1 plus b by s plus 3. Understand that. Why we are doing this? See, we don't know what to do if this is given to apply inverse Laplace transform. Understand, when we are applying inverse Laplace transforms, okay, the given signal needs to be in this particular form. See here, it should be either 1, it should be 1 by s or 1 by s square or 1 by s plus a or anything that we have on the right hand side. Okay, we need to have the signals in this particular form. Okay, so to bring the given x of s into this particular form, we are making use of the partial fraction expansion like this. See, which form we have 1 by s plus 1, right? So do we have 1 by s plus 1 in, see, 1 by s plus a we have. So if you have 1 by s plus a, I know it is e power minus at. So that's why I need to bring it to the standard form so that I can apply inverse Laplace transform to get the time domain signal. But yes, you can apply the inverse Laplace transform here, but without finding out a and b, we're not supposed to do that. So how to find out a and b, you all know. Okay, so that part I'll leave to you. I'm not getting into that part. Okay, so do that and get your a and b. Your a is 1 and b is also 1. Fine. So therefore x of s looks like what? Therefore by partial fraction method we have obtained our x of s to be this. Isn't it? So this is called this as equation number 1. Fine. Just say we know that Laplace transform of e power minus at is what? Is 1 by s plus a. We know this. Okay. So therefore, if we apply inverse Laplace transform on this, which exponential we are going to have is what we are looking at. Therefore, applying inverse Laplace transform on 1 implies x of t is equal to what? E power minus t plus e power minus 3t. Everybody understand this point? So this is how the things look like. So this is how we will be applying the inverse Laplace transform. Okay. So, but before applying inverse Laplace transform, our S domain signal should be brought to the proper form using the partial fraction expansion. Okay. So you should not have any problems doing this. Now the second problem, very similar. Okay. X of S is given to be S square plus 2s plus 5. Fine. Then in the denominator we have s plus 3 and s plus 5 squared. So it's already in factorized form. So that means there are two repetitive roots. How many root is there? It's a 3 root product, third order equation. Understand? So one root is minus 3. Okay. The other two roots are minus 5 and minus 5. That's why we have s plus 5 to the power 2. Understand it? So how can I expand this by partial fraction method? I can expand this in partial fraction method in this form. That is a by s plus 3. So we have 3 roots because the denominator is a cubic equation. Okay. So we have 3 roots. Whereas here it was a quadratic equation, square root equation. to the square. S square you will have as the maximum power. S cube you will have here as the maximum power. Okay, that's why you have three roots. So it's a third order equation. Fine. So plus b by s plus 5 plus c by s plus 5 square. So this is how we expand this particular x of s using partial fraction method. See, we are having this in standard form now. Okay. Now you do this to obtain ABC. I'll give you ABC. A is 2, B is -1, and C is -10. Okay, so therefore x of s becomes what? Therefore x of s after partial fraction expansion would look like 2 by s plus 3 minus, we have there b, that's why it's minus 1 by s plus 5. Okay, we have minus in c also, so it's minus 10 by s plus 5 whole square. Now again, this is in the standard form now. So if you go back and see, okay, when do we have this square to this s plus 5 term? Okay, so go back to your standard table. See, we have 1 by s plus a, right? When do we have 1 by s plus a squared? See here, when do we have 1 by s plus a squared? When we have t along with this exponential. Okay, when it is 1 by s plus a, it is just e power minus at. When we have 1 by s plus a square, it is t into e power minus at. So this and this is what we need to be aware of. So to obtain the inverse Laplace transform. Understand that? So let's say that now. We know that, call this as equation number 1. We know that Laplace transform of e power minus at is 1 by s plus a, and Laplace transform of t into e power minus at is 1 by s plus a squared. So these two results you need to remember. Fine. After getting x of s in its standard form. Okay. So therefore, applying inverse Laplace transform to 1. Therefore, applying inverse Laplace transform to 1 implies x of s would become x of t. Inverse Laplace transform of 1 by s plus 3. 2 you keep aside, and inverse Laplace transform of 1 by s plus 3 is e power minus 3t. Okay, similarly, the second term would have e power minus 5t. Okay, the third term is minus 10. Okay, t into, because there is square in the denominator, so t into e power minus 5t. So this is how we obtain the inverse Laplace transform given x of s. Understand this? Yeah. Now we shall see an indirect problem. These are all direct problems. Okay, let's see an indirect problem wherein these inverse Laplace transforms are used. Okay, so take that as your third problem. Fine. So what is this third problem telling you? Everybody take down the problem statement. This is a little tricky, or you need to have that understanding before you solve this. Fine. So everybody copy this problem now. Solve the second order differential equation. second order differential equation. Solve the second order differential equation, that is y double dash t plus 5y dash t plus 6y of t equal to x of t with initial condition with initial conditions y of 0 equal to 2, y dash of 0 equal to 1, and x of t, the input x of t is e power minus t into u of t. So you have to understand this problem. Okay, see, you have second order differential equation and you're asked to find out the solution to this, solve the second order differential equation. So what needs to be done if you're asked to solve this equation? Which is the unknown? Solving means finding out the unknown. Which is the unknown? Y of t is the unknown. So this is differential equation. Mind you, see here, this is differential equation, just the note. It is different type of representation so that it would become easier to type actually in the question paper. Okay. So what is the meaning of y double dash t? What is this? This is d square y of t by dt square. Understand? Similarly, what is y dash of t? It is first order differential. It is d of differential of y of t with respect to t. So you should know this. So they have how to understand this is differential only because here this is very clearly told is first order, second order differential equation. So we need to solve this. Okay, so we have to make use of a property here, differentiation in time domain. What is differentiation in time domain property telling us? Everybody see here. This is a differentiation in S domain that we have seen. Okay. There is another property which talks about differentiation in T domain, time domain differentiation. So if you have x of t, it is Laplace transform x of t is x of s. Understand that? Now, if you have the differential of x of t, if you have differential of x of t, first order differential means s into x of s minus x of 0. If you want the second order differential means it is s square x of s minus s of x of 0 minus x dash of 0. So this is the initial condition which would be given. So that's given in the problem. Everybody understand that? So see here, that's why in the problem they have given us what is y of 0 and what is y dash of 0. These are all initial conditions which would be there when we apply the Laplace transform to the second order differential equation here. Understand that? Okay, so let's do this. Solution using the differentiation in time domain property or time differentiation property, differentiation in time domain property, Laplace transform of the second order differential, okay, is given as s square into capital Y of s minus s into small y of 0 minus small y dash of 0. See, y of 0 is given. Okay, see, y of 0 is given and y dash of 0 is also given. Similarly, the Laplace transform of the first order differential. What is that? It is s dash s1 into y of s minus y of 0. Okay, so this is what is understood. This is something that we need to know. Okay, so therefore applying Laplace transform on this second order equation. Okay, how does it look like? Okay, given y dash of t, y double dash of t, that is second order differential, plus y dash of t, first order differential, plus 6y of t, okay, equal to x of t is there, right? So what is x of t? See, x of t is given. Okay, let me write that. X of t is given. Okay, so x of t is written as what? X of t is given to be e power minus t into u of t. Since u of t is there with another function of t, let's ignore this when we are writing x of t. Okay, so substituting x of t equal to e power minus t. Okay, let's say u of t, but u of t will not consider because it is function of t. Let's write, but we shall not consider. So therefore, what we have is y double dash of t plus 5y dash of t plus 6y of t is equal to e power minus t u of t. Okay, now they have asked us to solve this. They have asked us to solve this. Solving means what? Solving means obtaining y of t from this second order differential equation. Solving second order differential equation means solving the unknown. Which is the unknown? Y of t is then we have to find out that. So how to find out y of t is what we are learning. Okay. So now let's apply the Laplace transform. Because we know if you apply Laplace transform, how does it become? So we know that, right? So applying Laplace transform, everybody do that. Applying Laplace transform, what would happen? So you have seen this, right? So you have this. So seeing this, you can write. Okay, so it would become a big equation. So it's s square y of s minus s y of 0 minus y dash of 0, the first term, plus s y of s, okay, then you will have minus y of 0, right? Then what we can do, so these are all let's put them in brackets. You will understand this first term, this is for our second term, okay, but when we are writing the second term, see here we have 5, right? 5, okay, so that means 5 I didn't consider here. There is a 5 here in the second term. Fine. Then plus 6 y of s equal to, what is Laplace transform of this? E power minus 8 is 1 by s plus 1. So we have applied Laplace transform on this equation now. Fine. Now bring it to the form wherein we'll have y of s. So I need to obtain the equation for y of s here. Okay, so substituting, first we have to substitute what? Y dash of 0 as 1 and y of 0 as 2. Okay, implies what? Implies s square capital Y of s minus 2s minus 1 plus 5s y of s minus y of 0 is 2, right? So 2 into 5 would become 10 plus 6 y of s equal to 1 by s plus 1. Is that okay with you, everybody? Now, if you take y of s common here, if you take y of s common, what would be there? See here, if you take y of s common, you will be left with s square plus 5s plus 6. Okay, and then you'll be left with minus 2s and this and this and this would give you minus 11 equal to 1 by s plus 1. So finally, if you work out, you will get your y of s equal to 1 by s plus 1 is there on the right hand side. Take 2s and 11 onto the right hand side would become plus 11 and plus 2s on the right hand side divided by s square plus 5s plus 6. Why did we obtain y of s? Because we are asked to solve this problem or this differential equation. So that means we have to obtain y of t. Okay, so we have y of s, bring it to the proper form and apply inverse Laplace transform. You'll have y of t. That is what is going to be the solution to the second order differential equation. Is that understood? So bring it to the proper form, everybody. See how it ends up. So how does it look like? Go on, everybody. So if you work out, so in the proper form, it would look like 2s square plus 13s plus 12 divided by s plus 1. Okay, this s plus 1 would be taken in the denominator, and the fraction, the factorization of this differential second order differential equation in the denominator would give you s plus 2 and s plus 3. Understand this point? So it can be arranged as a by s plus 1 plus b by s plus 2 plus c by s plus 3. Fine. Now what? So therefore you can go with finding out a and b. So a would happen to be 0.5, b is 6, and c is minus 9 by 2. That's minus 4.5. Okay, so therefore y of s looks like what? Therefore y of s would become what? Half into what? 1 by s plus 1 plus 6 into 1 by s plus 2 minus 9 by 2 into 1 by s plus 3. Now this is what is the form we require to apply the inverse Laplace transform. Okay, therefore applying inverse Laplace transform implies y of t is equal to what? Half into e power minus t plus 6 into e power minus 2t, the inverse Laplace transform of this, minus 9 by 2 e power minus 3t. So what is this now? This is y of t we have obtained, but what is this y of t? Y of t is the solution to the second order differential equation that they had given. So how did we solve that? by using the property of Laplace transform, that is differentiation in time domain. So we ended up getting y of s by applying that property. But we know how to obtain y of t given y of s. So that is how we obtain y of t, and that y of t is actually the solution to the second order differential equation. Is that understood, everybody? Okay. Now, why I took this problem in the inverse Laplace transform topic is because we have to apply inverse Laplace transform. Similarly, if you see the convolution problems, even the convolution problems can be involved in this. Understand? So I'll give you one convolution problem for assignment. You can take this assignment now. Okay. Assignment. Just take this. This would be problem number, under this only we'll take. Okay. So this is, okay, assignment number 1, we shall say under this. Fine. So everybody just copy this. Find the convolution of, find the convolution of x of t and x of t. So we are convolving two signals. Which are those two signals? X of t and x of t itself. Where x of t is the rectangular pulse shown in figure. What is that rectangular pulse? X of t. See, everybody. Copy this. What is shown here? X of t. Fine. What is this x of t? X of t is this. This is 0. Then in between we have t. Then we have 2t. Okay. The amplitude is 1. And this is time axis. So this is x of t. Okay. So you need to convolve x of t with x of t. You have to obtain the convolution of x of t and x of t. What is that? Hint I'll give you. You should say, let y of t equal to convolution they're asking, right? X of t needs to be convolved with x of t. Okay. So what you would do? You would apply Laplace transform. Apply Laplace transform. Okay. You will get y of s, x of s into x of s. Okay, by applying Laplace transform. By applying inverse Laplace transform, you will find y of t. So what is this? X of t is not directly given as mathematical equation. You need to obtain that x of t from this. Okay, and let me give you the answer also. This is the answer for the assignment problem given. I hope everybody would solve this. So you solve this, that will boost your confidence. Understand? Yeah. So get this answer yourself. Okay, you learn how to obtain the mathematical expressions. Okay, and you'll be able to apply the Laplace transform once and then the inverse Laplace transform to get y of t. Okay.